All right, here we go. Lesson 5.3, and we are dealing with exponential functions with base b. And so you've seen this kind of in a different form, but hopefully you can connect it. We've got y equals a times b to the x minus h, and then plus k. All right, and let me just relate it to something that you've already seen before, where our A amount in terms of t and based on time, A is a function of t, was equal to the initial amount, A sub naught, times 100%, your initial, because as soon as you put in, you've got 100% of something, plus whatever your percentage rate of increase or of decay was, so times the rate, and then that to the t power. And so hopefully you can kind of connect some of these things, that our initial rate, that's just like the A is right here. Our B value is our 1 plus R. T, it's taken on a little bit different form, but we'll talk about this in just a second. It's really just the same thing as well. And then we'll have this plus K at the end. But these are kind of two different ways to look at, this one's specific for rate of growth and decay. And here's kind of more a generic exponential function, a graph of an exponential function. So here we are. Think of those terms that all of the graphs we've done like that with interest or depreciation or whatnot, A is going to be positive. And I suppose A could be negative, in which case it would flip the graph and look a little bit different. But nothing that I can think off the top of my head anyways, would you do that with it? Because we're dealing with initial amounts of something. That's going to be our A value. B is what like our percentage rate. And so when it was your 1 plus, like let's say 6%, so 1 plus 0.06, you got interest. It grew. It was an exponential growth graph. And so B there is greater than 1. On the flip side, when you had decay, it was minus that 6%. And so if B is greater than 0, but less than 1, you're going to have a decay graph. The H, so let's talk about H now. A is really going to always be positive for us. I suppose you could have a negative technically, but in which case, again, it would flip it downward. But our B value, if it's greater than 1, we're talking about growth. But if it's less than 1, still greater than 0, however, then we're talking about decay. Now, if this is typically, think back to our financial issues, this was t. We had that 1 plus r to the t power, or that was time. Now think of what h is going to do here. If we're subtracting from that amount of time, everything's going to be happening later and later, and it's going to shift the graph to the right if we're subtracting a positive h value. Remember, you want to think of this kind of as a timeline here. And if I take away from the x value that I plugged in, so if I plugged in, for example, 8, but then I subtracted 2h from it, now everything that was happening at 8 is now going to happen at 10. It just is happening later on in the timeline. If h is negative, then really I'm adding, and it's happening sooner. So where if it was at 8, but now it's a negative 2, it's going to happen 2 years or 2 weeks or whatever the time period is earlier, and now it's going to happen at 6. So h moves your graph horizontally, either left or right. And then plus k. So notice how k is really unattached from the rest of the function here. It's an afterthought. The b's already been taken to its exponent. We've already multiplied it by a, and now at the very end we're adding or subtracting some number. And what that's going to do is move the graph up or down. And it will actually have an asymptote down at the bottom. So if there's no plus k, then the asymptote is at 0. Think of depreciation. We talked about in class about the iPhone, that maybe if you bought it on eBay right now, it'd be about $500. But then maybe after a couple months, now it's down to only 250, and after another couple months, now it's down to 125, and it keeps on cutting down, cutting down, cutting down. We said, what if it cut in half every number of months? But if it keeps on cutting in half, it's never going to get less than 0. In fact, it will never even get to 0, because it's going to keep on getting cut in half, but it's keep on being a positive number greater than 0. So our asymptote happens at whatever the k is. If it's being added, then it moves our asymptote up. If it's subtracted, then it moves the asymptote down. All right, so let's kind of be a little bit more explicit about that. H, what does H do? It controls controls the horizontal shift, where K, and actually in class a lot of times I'll change that to V, but K changes your vertical shift. Vertical shift, like moving it up or down, which by moving it up or down controls your horizontal asymptotes. All right. Hope that helps.